Hi friends, welcome back to physics classes. Today we are going to learn about the new topic in the physics, that's Newton laws of motion. Now let's learn about the laws of motion which are discovered by Newton. There are three laws of motion which are discovered. First one is Newton's first law of motion, Newton's second law of motion, Newton's third law of motion. Now let's discuss one by one. First one, Newton's first law of motion states that a body at rest or uniform motion will continue to be at rest or uniform motion until and unless a net external force acts on it. It means a body which is at rest or a body which is at uniform motion will be at rest or uniform motion until and unless any external force is applied. Until and unless any force is applied on it, it will be either in rest or in uniform motion. If it is in rest, when an external force is applied, the body starts its motion, or when it is in uniform motion, when force is applied, it may stop or increase its motion or increase its speed. Here is a small example of a football with external force. Here is a ball. An object doesn't move until an external force is applied. Here no external force is applied on this ball, so it doesn't move. When an external force is applied, it moves. The ball starts to move. When an external force is applied on the ball, it starts to move. Initially it was here, finally it moved to here. Initially it was on point A, but finally it moved to point B. When a force is acted on the point or the ball, it changed its position. This is the force. About this force we are going to discuss in the second law of motion. Now that's it. The first law of motion is that a body which is at rest or in motion will be at rest or in motion until and unless a net external force is act on it. Next, second law of motion. Newton's second law states that the acceleration of an object as produced by net force. It means an acceleration of an object produced by force is directly proportional to magnitude of net force. It means it's directly proportional to the magnitude of net force. It means magnitude of linear momentum. Here we are going to learn about also linear momentum and its net force. It's directly proportional to the magnitude of net force in the same direction as net force. Acceleration moves on in the direction of net force, and it is also inversely proportional to the mass of an object. It's inversely proportional to mass of the object. Here when we apply some acceleration, there will be some force. When we apply more acceleration or more force, then will be more acceleration. Less force, less acceleration. More force, more acceleration. Here force is directly proportional to acceleration. Next, now let's learn about linear momentum. Here linear momentum is a vector quantity and is defined as product of mass of an object and its velocity. Here it's defined as product of mass of an object and its velocity. Linear momentum means product of mass and its velocity. Product of mass of an object and velocity of an object. P denotes linear momentum, m is the mass of an object, and v is velocity of the object. Here now according to this definition, let's frame the formula. Let's solve the force formula according to definition. Here F is directly proportional to linear momentum by time. So we can frame a formula with this. F is proportional to P by T. So F is equals to F inverse proportional to, here P we can write as mv mv minus mu by t. F proportional to, here we can take a m common, so we can write v minus u by t. So F is directly proportional to m into, here v minus u by t can be also told as a, so F is equals to k m a. F is equals to k m a. Here k is constant, m is mass of the object and a is the acceleration. With this we can find the force of the object. Also we can write this formula as F is equals to m a. Now Newton's third law. Newton's third law states that there is an equivalent opposite reaction for every action. Newton's third law states that there is an equivalent opposite reaction for every action. Here is an example of that. Here is an example of Newton's third law. The rocket, when moves up into the space, it in the space station or in the rocket launching center, when will be launched, there will be the huge fire or huge gas is created, because this, when rocket moves up, produces the enormous or the huge amount of force downside to move upward. It produces enormous amount of energy. This makes the rocket move up. This tells about the Newton's third law. When the rocket wants to go up, it pulls or it has some energy downward so that it can move upward. So thank you. Please like this video if you got the information about the Newton's laws of motion and explanation of the derivation of the formula F is equals to ma, and share and subscribe to our channel, that's Study to IIT. Have a great day.